Hello students, in the last class we discussed about the preparation of the dichlorine and some chemical properties like reaction with ammonia, metals and non-metals and reaction with the hydrogen. In this class we can discuss about very most important reactions of the dichlorine like reaction with alkalis means the bases. In our syllabus, they mention two alkalis like NaOH and calcium hydroxide, NaOH and CaOH twice. First, you take with the sodium hydroxide. In that one, there are two cases. One case is the chlorine reacts with cold and dilute NaOH. Cold and dilute NaOH. Reaction with cold and dilute NaOH. The product formed is the sodium chloride and sodium hypochlorite. Sodium hypochlorite. For that one, you have to write the reaction. Very most important for the competitive exam. They mention just cold and dilute NaOH only. You take NaOH. Here below that one, you take cold and dilute. Cold and dilute NaOH. If reacts with chlorine, the product formed is one major product is sodium chloride, and sodium hypochlorite formula is NaOCl plus H2O. Most important reaction. Then balance this reaction. 2 NaOH, the reaction get balanced. This is the reaction with cold and dilute NaOH. Second case is the chlorine reacts with hot and concentrated NaOH. With hot and concentrated NaOH, then the product formed is same. Sodium chloride. One is sodium chloride and another one is sodium chlorate. For this one, you have to write the reaction. That is NaOH. You mention hot and concentrated. Reacts with the chlorine. Cl2. Then the product formed is sodium chloride, NaCl. Sodium chlorate formula is NaClO3. We are using potassium chlorate for the dioxygen preparation. Potassium chlorate is KClO3. Like that, sodium chlorate is NaClO3 plus H2O. You have to balance this reaction by using 6 NaOH and 3 Cl2 forms 5 NaCl plus 3 H2O. These are very most important one. Just they mention cold and dilute or hot and concentrated. With cold and dilute NaOH, you get sodium chloride and sodium hypochlorite, NaOCl. With hot and concentrated, you get NaCl and sodium chlorate. Then third alkali is slaked lime. That is chlorine reacts with slaked lime. Slaked lime formula is CaOH twice. This is called slaked lime. When chlorine reacts with slaked lime, it results in the formation of bleaching powder. These are all very most important reactions. When chlorine reacts with slaked lime, that is slaked lime formula is CaOH twice. This is the slaked lime, calcium hydroxide. When reacts with the chlorine, The bleaching powder formula is CaOCl twice. CaOCl twice. In addition to that one, CaCl2 plus H2O. CaCl2 plus H2O. To balance 2CaOH twice, 2Cl2, then 2H2O. This is the bleaching powder. Actually, in first year we are using bleaching powder formula as CaOCl2, but in second year they mentioned that bracket with the OCl twice, but in first year they consider only CaOCl2, that is CaOCl2. If they ask oxidation state in competitive exam, they can ask the oxidation state of the chlorine in bleaching powder. You have to observe the option that CaOCl2 can be taken as Ca2 plus and OCl2 2 minus. OCl2 2 minus. OCl2 2 minus. That is, you can split like this: Ca2 plus, one as Cl minus, another one as OCl minus. From this Cl minus, you take oxidation state as the -1. From this OCl minus, here oxygen as the -2. Oxygen oxidation state as -2. -2 plus x equal to -1, then x value equal to +1. That is, if the given two options like oxidation state of the two chlorine atom, one chlorine as the -1, in another chlorine atom as +1. In some cases, they can take only one, that is by using this one, that is CaOCl twice, CaOCl twice. Here 2 plus, here 2 minus. Then you can consider this one as OCl minus. There are two OCl. Each OCl charges as -1. By using this one, you can calculate the oxidation state as from oxygen it is -2 plus x equal to -1. Then x value it is taken as +1. If they given only one oxidation state, then you use this formula CaOCl twice. They are given two oxidation states, then you take CaOCl2. Then one chlorine has -1 oxidation state, another chlorine has +1 oxidation state. This is important for the competitive examinations. You have to remember the oxidation state of the chlorine in bleaching powder. It is -1 and +1. Then the composition of the bleaching powder is as CaOCl twice, CaCl2, CaOH twice, and 2H2O. This is the composition of the bleaching powder. Entire composition of the bleaching powder is CaOCl twice. That is sodium hypochlorite. This is commonly called as calcium hypochlorite. CaOCl2. This is about the reaction with the alkalis. One is cold and dilute NaOH. With cold and dilute NaOH, sodium chloride and sodium hypochlorite is formed. With hot and concentrated, you get sodium chloride and sodium chlorate. With silicate lime, product is the bleaching powder. You have to practice the reaction. Note down these three reactions and practice. Very most important one. This is about the reaction with alkalis. Next, you consider the oxidizing property. Next one is oxidizing property. This chlorine water, already we have discussed that it is yellow in color. Chlorine water kept for long time. Chlorine water kept for long time, it loses its yellow color. Due to the formation of the HCl and HOCl, sodium hypochlorite, not sodium, this is one is an hypochlorous acid, one is HCl and hypochlorous acid. Then this hypochlorous acid HOCl further decomposes to give HCl and nascent oxygen. This nascent oxygen is responsible for the oxidizing property. Hence, chlorine water behaves as an oxidizing agent. Why chlorine water is an oxidizing agent? Means chlorine water kept for long time, it forms HCl and HOCl, hypochlorous acid. This hypochlorous acid, HOCl name is called as an hypochlorous acid. This hypochlorous acid that decomposes to give HCl and nascent oxygen. This property, due to this one, we can consider chlorine water is an oxidizing agent as well as bleaching agent. Bleaching property removes the color. Then you consider some of the oxidizing properties of the chlorine. These are all important for completing the equation. First one is it oxidizes iodine into iodic acid. It oxidizes iodine into iodic acid. That iodic acid formula, that is the reaction is I2, chlorine water, Cl2 plus H2O. Iodic acid formula is HiO3 plus HCl. This is the reaction. To balance this reaction, 5Cl2, 6H2O, 2HiO3, 10HCl. This is the reaction. Chlorine water oxidizes iodine to iodic acid. Similarly, it oxidizes sulfur dioxide into sulfuric acid. Chlorine water oxidizes sulfur dioxide into sulfuric acid. That is, reaction is SO2 plus Cl2 plus H2O, chlorine water. Product formed is sulfuric acid and HCl. To balance this reaction, 2H2O, 2HCl and 2HCl. This is the next reaction. Then similarly, that reoxidize sodium sulfide into sodium sulfate. Sodium sulfide formula is Na2SO3. Sodium sulfide. Chlorine water, Cl2 plus H2O. Sodium sulfide into sodium sulfate, Na2SO4 plus HCl. You have to balance this reaction. Already they have to consider 2HCl reaction get balanced. Then similarly, it oxidizes ferrous sulfate. Ferrous sulfate into ferric sulfate. It oxidizes ferrous sulfate into ferric sulfate. That is, ferrous sulfate formula is FeSO4 plus chlorine water, Cl2H2O. Then that forms ferric sulfate, Fe2SO4 thrice plus HCl. Then to balance this reaction, 2FeSO4, then 2HCl reaction get balanced. This is about the sum of the oxidizing properties. You have to remember, you have to practice these oxidation reactions. That is, one is iodine to iodic acid, sulfur dioxide to sulfuric acid, sodium sulfite into sodium sulfate, ferrous sulfate into ferric sulfate. Similarly, you can consider the bleaching action bleaching action. Bleaching action means this colored substance, any colored substance is present that becomes to colorless. Colored substance into colorless substance. This chlorine water is a powerful bleaching agent. Chlorine water is a powerful bleaching agent. It is that bleaching action is due to oxidation. Due to that of the oxidation property. Due to oxidation, this chlorine water behaves as a bleaching agent. That bleaching action, that bleaching effect of chlorine, it is taken as the permanent. Once you treat chlorine, colored substance with chlorine water, that becomes colorless, it is permanent. Bleaching action of chlorine water is permanent in nature. Then last one is you consider reaction with hydrocarbons. In the reaction with hydrocarbons, if saturated hydrocarbons reacts with chlorine, saturated means single bond. Saturated hydrocarbons reacts with chlorine, they forms the substituted products. While unsaturated hydrocarbons reacts with chlorine, they forms the addition compounds. That is, with saturated hydrocarbons, substituted products form. With unsaturated hydrocarbons, addition products form. For example, you take methane. Methane reacts with chlorine in the presence of the sunlight. You get one of the hydrogen replaced by the chlorine, methyl chloride and HCl. This is the substituted product. Or you take CH2, double bond CH2, and ethene, that is C2H4. C2H4 reacts with chlorine, then it forms CH2. Here one chlorine get added, double bond converted into single bond, that is CH2Cl. This is commonly called as an vicinal dihalide. Already in haloalkane we are considered the dihaloalkane. If two identical halogen atom bonded to same carbon atom, they are called as a geminal dihalides. If they are bonded to adjacent carbon atom, then they are called as an vicinal dihalides. Bonded to same carbon atom, it is called geminal. If bonded to adjacent, then it is called as a vicinal. These geminal dihalides we are called as an alkylidine halides. Geminal are called as an alkylidine halides. Vicinal are called alkylene dihalides. Geminal are called alkylidine halides. Vicinal are called as an alkylene dihalide. Here vicinal dihalide is formed. That vicinal dihalide name is an 2 carbon atom. Then it is called as an ethylene dichloride. Ethylidine chloride is different. Ethylidine chloride means CH3CHCl2. This is ethylidine chloride. This one is an ethylene dichloride. This one is an ethylidine chloride. Ethylene dichloride. Here vicinal dihalide is formed. That vicinal dihalide name is an ethylene dichloride. This is about the reaction with hydrocarbon. Then consider the uses of the dichlorine. One of the used as a bleaching agent. already we have discussed the bleaching property. Bleaching agent used in the manufacture of the dyes, that is colors, used in the manufacture of dyes, drugs, used in the manufacture of dyes, drugs, and organic compounds like carbon tetrachloride, CCl4, chloroform, CHCl3, DDT. In the preparation of the DDT, we are using dichlorine. Then for sterilizing the drinking water, then in the preparation of the poisonous gases, like phosgene formula is COCl2, or maybe of mustard gas. Mustard gas formula is C2H4Cl twice S, C2H4 twice Cl twice S, mustard gas, or maybe of the tear gas. Tear gas, for example, is CCl3NO2. This is called as a chloropicrin. These are all the poisonous gases. Chlorine is used in the preparation of poisonous gases like phosgene, COCl2, mustard gas. That mustard gas formula is C2H4Cl twice S, or maybe tear gas. The tear gas formula is CCl3NO2, commonly called chloropicrin. This is about some of the uses of the dichlorine. In the next class, you can study about the another compound of the halogen is HCl.